So without further ado, welcome. This is Getting Started with Docker on AWS. Who here is new to Docker? Woo! OK, so that's why we have Getting Started sessions. So we are going to kick it off. So Docker 101. So what is Docker? Docker is an open source platform for running distributed applications. Create something called a container. So applications built in Docker run in these containers that you can build, ship, and run on your platform of choice. So that might be ECS, it might be Kubernetes, it might be Mesos, it might be something you built yourself. But you can build those containers, and then you can run them anywhere you'd like. So Docker containers are built from a series of instructions called a Docker file. So to run a Docker container locally, we could follow some commands, right? So Docker build app, and then Docker run app. And that's a really extra simplified version. But basically, the Docker file is a series of instructions, right? And it follows something like instruction argument. So build or add X, copy X. So very similar format. It's the instruction and then what you're going to do. So we've covered a little bit about what these containers are. But how can you start working with containers in production on AWS? So the easiest way to do this, Amazon EC2 container service. It's now Elastic Container Service. Highly scalable, high performance container management system. So what do you need this for? So containers are actually a lot of work. So it used to be that the kind of the traditional way of doing things was a monolith. So I built my app. It was maybe all in one piece, right? It was all one repo. It was whatever language I built it in, it doesn't really matter. But it was all kind of one piece. It had a bunch of services. My application basically had a bunch of jobs. It served lots of functions. It did lots of stuff. What a lot of people have been doing pretty recently is something called microservices. So you've decomposed your monolith. So it's a bunch of smaller services, and that each have their own job. So with that, though, as you can imagine, going from one piece, so one single application that served many functions, to many separate services that all served each, hopefully, one function, there's some heavy lifting that goes along with that, right? So I used to scale one piece, but now I have to scale 100. I used to deploy one piece, and now I deploy 200. So there's lots more little moving pieces that go into running these containers, which makes sense because the containers are a lot more pieces also. So something like ECS is an orchestration platform. So it helps you with a lot of these moving pieces. So how do you install and operate and scale all of these containers? So what does this mean kind of in practice? So the first big thing is cluster management. So in ECS, you have a pool of resources. So those are all EC2 instances. So how do I manage the instances that belong to that cluster? So how do I add new ones? How do I take them away? How do I update them when I have to change something? And then there's container orchestration. So all of those pieces, how do I manage those little boxes across my pool of compute resources? How do I scale them? How do I deploy them? How do I fix them when something's wrong? How do I update them? How do I make a change? And then deep AWS integration. And I think that deep AWS integration is something that we have on a lot of slides. But what does that actually mean? And what that means is that, so when I first moved to ECS, right, so I had a monolith, and it wasn't even that big, right? But I moved it over, and I moved it to ECS. And when I was looking at kind of what I wanted to move to, one of my biggest things was that there was a lot of new things for me with containers. So it was already a pretty steep learning curve. So I was a DevOps engineer. So how do I move from kind of managing my one giant piece to managing lots of little pieces? And that was already a lot for me to handle. And I was a team of two. So part of my criteria when I was looking for something else to handle these containers, so I decided that I wanted to move, was how can I use the things that I'm familiar with already? So EC2 auto-scaling groups, Route 53. I wanted to put things in S3. I wanted to be able to monitor things with CloudWatch. And that's really what I mean with deep AWS integration. So the CloudWatch work, so I can use other AWS services to deploy, to log, to monitor, to scale, to manage identity, to handle security. So that's what I consider with deep AWS integration. So how can I kind of outsource some of those other tasks that I need to worry about when I'm building a good app with containers? How can I get something else to help me so that I can focus on other stuff like building my actual service? So ECS, part of this, right, is that this is my platform, but I don't really want to have to manage the platform either. I don't want to have to manage my containers, and I don't want to have to do anything with the platform. So ECS, I don't install any agents or anything, but I can use it to deploy, to manage, and to scale my containers. So that's three big tasks. So we will unpack kind of how I can do those tasks and how I can work with them with Docker. So this is what I just talked about. I went out of order. So how does ECS map to traditional workloads? So I added this after it was most of the questions that I got afterwards. Was for a lot of people, this is really new. So being able to do, working with containers is pretty new. Working with Docker is pretty new. So how does ECS kind of map back to those things that I'm familiar with? So your first thing is an instance, and that is just a regular EC2 box. So once you've registered that box to the cluster, your tasks will run on that instance. And a service is a layer that manages and places a task. And then a task is that container wrapper and configuration around a process. And that is, by the way, is pretty much just what a container is. It is a wrapper around a process. So if you've written your container properly, there's maybe a couple processes, but in general, there's only one. So it's running application.py, or it's doing entry point file.sh. So all it's really doing is it's doing some setup and configuration and then running a process. That is all the container is. It's not really even magical. It's just a little box around a process. So what ECS does is it provides you that pool of cluster resources, which is your instance. It gives you a service, which manages and places the tasks for you, which is important, and we'll get back to that. And then a task, which is basically managing those containers. So in practice, what this ends up being is I write my container locally, right? And from my development environment, that might be something like, OK, from container name, install a couple things, move my code over, requirements.txt, and then run my Python application. So that's all that is. That's a box. I push it up. Maybe it goes to GitHub. Maybe it goes to code build. I push it to ECS. And then what that is in ECS is a task. That container just turned into a task. And a service is what's letting me scale that task up and down and place it on a pool of instances. So just some ECS terms for what we're actually doing with those containers. And what that maps back to is all those things that we just talked about, right? So how do I deploy, manage, and scale my containers? That's what that does. So how does this actually work? So this is it's actually basically an architecture diagram, but it's shaped like a spaceship now, which I think is better. If I actually wish if all my architecture diagrams were shaped like spaceships. So in a real kind of architecture terms, though, we'd end up with our drawing for our load balancer at the top, and then it would go to a cluster. So and then all my cluster is a group of little instances or spaceships. But that's all it is. So my load balancer is just directing the traffic to the services in my cluster. So it's a really simple, I think, kind of outline for something that's doing quite a lot of work. So, but from a top down, all it really is kind of the same EC2 structure that a lot of you are familiar with, right? Is I have an auto-scaling group, and I have instances in it. Only instead of just my instances, I'm now directing traffic to the services themselves. And what this lets me do is it lets me break up my architecture. So previously, if I wanted to scale up or down, I had to scale up the whole service, which is every kind of job. So even if I had one piece that never got any traffic and one that got a ton of traffic, I had to scale the whole piece up and down. And now what I can do with microservices is that I can direct the traffic to the little individual pieces, so then I can scale with just the resources that it needs. So I can scale up just my messaging service, and my admin UI doesn't need to scale. Or I can do the other way around. So it lets me be a lot more powerful and a lot more flexible. So we're going to break this down. So our load balancer, and it used to be that it was just an ELB, but now it's an ALB. So an application load balancer, a network load balancer, or our load balancer classic. It routes my traffic to the instances. My cluster has more than one or more EC2 instances, and then each container instance runs one or more of my services. And these control two separate pieces, right? So a service is effectively controlling my deployments. And in ECS terms, that's something like the number of copies that I want running of a task. So if I have my web task, I have web task 1, web task 2. And every time that number increments, it's a deployment. So it's not only my deployment, but it's the contents of kind of my container and my task. So my service is controlling that. And my service is also what does my registering with my load balancer. So my load balancer, especially with an application load balancer, right, I can do path-based routing. So /web goes one place, /API goes to a different service. So my service is what registers with the load balancer, says, here's my target group, send traffic that looks like this to me. And then, if I need to, I write the rules. So that service is also saying, I need more copies of you. I need more copies of you. And then I need less copies. So, and you scale that up and down in response to other factors, right? So CloudWatch alarms probably. So stuff like CPU or memory or the number of messages in a queue. So a task definition, though, controls kind of everything else. So the container that you use, the environment variables that you use, the resource allocation, the logger, it's pretty much everything else. So your service is controlling the number of copies and how it talks to the load balancer, so how it receives traffic. And then your task is kind of everything that makes it unique. And when you look at how your architecture works with containers versus a monolith, is that we've made another shift too, right? So we've gone from managing a lot of stuff at the instance layer and then just running your application on top of that to running a lot less at the instance level and putting a lot more of the configuration in the container itself. So this container basically is setting up its own environment to execute your code in, and then it's running its own code. So everything that used to just be at the instance level and your application is now all wrapped up in that little container box. And that lets us do some really powerful stuff, right? Because if you think about the kind of the development process now, I can do that from the beginning. So my little box, I can build locally, I can run locally, and I can ship that same box from my development environment to a staging environment to a production environment. I can just ship that little box everywhere because it carries all of its configuration with it. So it lets me do a lot less on the actual instance that it's running on and keep everything just in its little container box. So how can I actually get started with ECS? So I want to build a cluster. I want to actually build something. I want to run it in production. How can I do that? So I've done a kind of a dual demo here, and it's not a real demo, but you can do these things from two ways, right? So you can do it from the CLI, or you can do it from the console. And I think everyone is like, oh no, the console. But there's actually some really great stuff though, right? So one is visual feedback. So if you're just getting started with ECS and these concepts are new to you, you'll get some really nice visual feedback from doing something in the console that you won't get from the CLI. So an error message, maybe. There's some first run wizards in there that can be really helpful. So if you're just starting out, I recommend poking around there a little bit first, because it will kind of help you kind of get your feet under you. But once you're kind of ready to get rocking, you can use the CLI. There's actually two CLIs that work with ECS. There's the regular CLI, the AWS CLI, and there's another ECS CLI. So you have a couple options there. I'm going to show you the actual CLI commands, but there is no shame in the console game. So if you're just looking to get started, definitely start there first. So how do I create a cluster? So there's a very specific kind of set of instructions here on this one, right? So so the way that I did this, I guess, when I was getting started is I kind of poked around with Docker. So I figured out how to build and run my Docker containers, and I did that locally. And then I can't really run ECS locally, so I kind of did all of my Docker research first. And then I went back up to AWS, and I was poking around the ECS console, trying to figure out how anything worked. And then the steps, it turned out, were pretty important that you did them in the right order. So they are in the right order, but you have to have kind of the framework set up so that you can deploy things really kind of smoothly. So the way that I did it locally, I built them up. You create your cluster first. So you need to have a place where all of your services can live. And we'll talk about why the order is important. So if I want to just get my cluster started, I can call create cluster. I give it a name. Since I'm creating it, it's going to return a bunch of information for me, but none of that information is really helpful other than it worked and it created a cluster. But there's nothing in it. But you can see where a lot of things will be important later, right? So I see my cluster name. I see that I have no instances running on it. I have pending tasks, 0. Running tasks, 0. Active services, also 0. But you can see, though, that by running this call, there's some information that's going to be pretty important for us later on, right? So after I've created the cluster, I had to create my task definition first. And I think that that's a little counterintuitive, right? Because when we were talking about the different pieces of ECS, we did cluster, and then service, and then task. Here is the gotcha here. So I have to create my task definition first, and then I have to register it to a service. But I need to have the task definition created in order to start the service. I can't start a service with no task definition. Some things that I have found out through experience, once you've created some of this stuff, you cannot undo it. So you can delete it. But what you can't do is change where it's registered. You can't change the load balancer that it's registered to. So take a second when you're doing some of this, when you're choosing your names, when you're registering things, because you can't always change them later. So we had to create our task definition first. And there's some information here that we have to look at, right? Because our task definition controls just about everything about our service. So from the container image that we're using to the resources that we give it. And a lot of this can be changed, right? So when I deploy my service again and again, I can change the container definition. I can change some values in the task definition. But have a thought when you're doing this. When you've created your container first, you've kind of built it from the ground up. So you've given it an image to look for. You've picked some resource things, and you can go back and tweak these later. But we have to register our task definition first. So the only thing that I really only care about here is the container definition. And that's where I'm getting my image and everything from. So I had to choose that first. And then I can call register task definition. I can also give this a JSON file, like everything else. AWS runs on JSON. So I can register my task definition. I'm giving it a family, and I'm giving it a container definition. Its family is its group. So in my case, it's reInvent. But what your family is basically the group of tasks that it belongs to. So it could be web, could be messaging, could be API. But I've named it reInvent because I have many things, but creatively naming things is not one of them. So that same call, though, serves a lot of purposes. So when I call register task definition, that's also going to be how I handle my deploys. So when you're doing this in an actual production environment, right, we're probably not going to do this by hand. So you're probably not going to sit there and be like, ooh, I'm going to register my task definition. You're probably doing that from your CI/CD system. So that same call, that same register call, is how you deploy also. So maybe how you deploy, right, is I would create my task definition, I'd update it through my CI/CD system, and then I would just pass it a new number. So from 5 to 6. So the same call for everything. I can either pass it a string or I can pass it the file. But in general, you would probably be creating this programmatically. You'd be updating your file programmatically. You'd be generating a template somehow that you could use to pass to your service. You have to create your service now. So we've created our task definition. We've registered it. But we're not doing anything with it. And you have a couple options here, though, because I can run that task definition just by itself. So if you go to the ECS console, you can just run tasks. So if you have a good example of this might be if I want to run a task in response to something else, I can just run my task. It does not need to be managed by a service. But if it's a long-running, it's basically if it's what I would consider a traditional service, like a messaging service or a UI service, something that has a job that you're often going to be running multiple copies, that you always want it running even if it's a different version. So what I consider a traditional service, I guess. That's how you manage long-running tasks. But that is not the only kind of task. So you can run a task outside of a service, but for your kind of traditional service jobs, you'd probably want to manage it with the service so that you can scale and do deployments and make sure that you always have a certain number of copies running. But you don't need to do that. You can also just call run task. I'm going to use the task that we just created to create a service. So I can name it something. I can call my service. I'm starting it with a desired count, though. So my desired count is 2. I always pretty much want to have at least 2. There are not very many tasks that I would run less than 2, unless I was just getting started or I was if I was maybe starting at like a development environment or something like that, I might start with 1. But in general, I want to always have 2. And that's so my load balancer has at least 2 to distribute copies between. But you'll also be scaling that up. We add a bunch more parameters here at the same call. So one of those might be placement strategy, which we'll look at in a little bit. And then this is where I register with my ELB, ALB, NLB. And this is what I said by stuff that cannot be changed. So once I've registered my service to a specific load balancer, I cannot change that. You have to go back and recreate it. That's also the same for family. So once I've created my family and I've registered it to a family, I don't get to change that either. So just a couple of things to note. Some of that information is immutable, so don't go back and try to change it later. But we can dig into some of my other parameters. So task placement policy. So this is a little bit newer, and I was actually just talking about this in a chalk talk because someone said, well, I have special custom instances and I've set them up in a special way, but they're only for specific tasks. And that's pretty much what you can do here, right? So there's a couple things that I can do, but I call create service, and I have a couple principles. I have a principle, I think, for ECS, right? And the first one, and whatever orchestration tool you end up using, and the first one is that I want to be able to customize things when I need to. But if I don't want to customize, I want to know that I can rely on kind of a sensible default so that someone else has done some research and chosen something that's going to work well for a lot of use cases. So I think that holds true for task placement policies too. So if you do not choose anything, you do not have to do this. You do not have to make a custom policy. You do not have to do strategies. You don't have to do constraints. You can do nothing. And what ECS will do is it will first check for hard constraints. Then it will place your tasks on the instances that had the fewest number of running tasks balanced across availability zones. So if I have a couple instances running, one has 10 tasks, one has 2, and they're both in different availability zones, if they both meet the kind of hard constraints, ECS will place it on the one with the fewest number of tasks. So that's the default behavior. You can write custom ones. So you have a couple different ones. So bin packing is pack them as closely together as possible. So if I have 2 hosts and I have one that has nothing on it and one that has a number of tasks and it just fits, ECS will choose the one where it just fits. So you can use that to kind of use your resources as closely together as possible. I think that's really good for things like development environments too, where you want to run not so many hosts and not so large of a host. But you can use that to kind of pack them until they're just full before you have to scale up and add another one. You can spread, which means distribute them as evenly as possible. You can do affinity, which means groups of tasks. So if I always want my web app, my web task with a messaging task, I can make sure that they're deployed in pairs. And this is actually my favorite, so it's distinct instance. So it used to be when you first started with ECS, right, that you had some things that you wanted to run on your hosts that didn't really belong as part of a service. So that might be like a daemon, right? So something that's going like monitoring or logging or something. And you had to run that basically yourself. So through EC2 user data, or you had to go and start it yourself. You couldn't really manage it through a service. But what's cool, though, is that you can use a distinct instance now, and that will place 1 per host. So if I have like a messaging daemon, like a container that I always want to run to collect logs, I can make sure that there's 1 and only 1 on each host that I've started as I auto-scale. You can also write some custom constraints. So this is what we were talking about a couple seconds ago, that you have custom ways to place things. So I've maybe made an instance that's really, I've customized it just for my workload. I can filter on that so that I can use them for just that kind of task. So if I have like a data task and I've set up an instance type specifically for running my data workloads, I can make sure that it's only placed on those. So what we didn't mention, though, is kind of how these get applied, right? So you have your default one, and it's applied mostly the same way, right? It checks for hard constraints, and then it tries to hit your strategy, and then it tries to hit your constraint. So what I think is important here, though, is that it used to be that you had three hard constraints. So you had port, you had memory, and you had CPU. And CPU and memory are still there, right? I cannot have more CPU or more memory on a box without getting a different box or doing something else. But sometimes I can get around the port constraint. So if I had a web app and it was on 8081 or something, What it used to be is that if I wanted to scale up my web app, if I wanted to have another copy of 8081, I'm stuck. I cannot make two 8081s on the same box. But what you can do now is that instead of having to scale up just so that I had another port 8081 available to scale up my web app, I can do something called dynamic port mapping through the load balancer. So I can give it a 0 as my host port and map that to my container port. And the ALB will allocate that port for me, which is effectively removing one of my constraints. So I can use my resources just a little bit more effectively. ALB, I think, is probably the best choice for running things on ECS because port allocation, but also because of path-based routing. So if I have /web/messages/API, I can handle those as target groups inside my ALB. Rather than having one ELB per service, I can use one ALB that handles multiple services, and I can route my traffic that way. You have options, though. You have the classic, you have ALB, and you have network load balancer. That's actually really cool for things like spiky traffic patterns, where it used to be that you'd have to worry at your load balancer level about how you would handle your traffic if it was really inconsistent. But you can do that with NLB now. Back to our little deployment. Editing this service deploys and also scales. So it sends out my new revision, but it also handles my scaling also. So it's the same call for pretty much everything. I can use my desired count to scale the service up and down, or I can change the task definition to change the revision. So these are all effectively deployments. So a scaling deployment and then also a content deployment. Although this is possible, though, from the console and the CLI, this is probably something that you want to handle with auto-scaling. So it means you're handling it in response to a different event. So I add a rule that says, OK, if I have more than 85% CPU, scale this up. If my queue length is over X messages, scale it back up. But then you also have to scale back down. So I probably don't want to just keep resources running if I don't need them. So for every auto-scaling rule, you want to have the up rule, but then you also want to have the scaling down rule so that I can scale back down when my traffic no longer warrants that. And then I had someone ask earlier that their rule wasn't working. And they scaled up at 85% of CPU, but then also back down again at 85% CPU. And then so nothing happened. And what you usually want to do is you want to leave a little bit of a gap. So I scale up at 85%, but maybe I don't scale down again until 75%. So that way, if my traffic is kind of spiky, I'm not trying to scale up and down and then just kind of undoing all of my changes over and over again. I scale up, and then I give myself a little bit of wiggle room. So I wait for the CPU to go below a certain number before I scale back down again. But something that you want to handle with auto-scaling, and you auto-scale at 2 levels. So you do it at the task, the service level, and then you do it at the cluster level as well. So the service and the task is handling how that service itself scales, and then the auto-scaling group is controlling your cluster resources. So how do I add and take away more resources from my cluster? So if my total cluster resources goes below 85% or below 10% that's available, add another instance to the cluster so that I have more places to place my new tasks. That's probably not where you want to leave it, though, right? So you can deploy this way. You could start a new cluster. You could add a task. You could add a service. But there's more that goes into running a production infrastructure, obviously, than just my little CLI demo. You can query the cluster state, but basically, you end up emitting a lot of events. So your clusters, your services, they all emit events, and you can consume those somewhere else so that you can learn from them, you can monitor, you can log on that. But I can consume these events through CloudWatch so that I can both auto-scale, but that I also can look at the events to say, OK, well, this deployment worked, or this deployment didn't. So I can really keep track of that by consuming the cluster events. You can stream that whole thing into CloudWatch, which gets me pretty close to real-time updates about both the container instances and then also the state of all those tasks. So what I would probably do with that is I would consume those events somewhere, or I would build something on top of that. So I would build a scheduler, or I would monitor my cluster state, or I would use it with something like Lambda so that I could take action then based on the events in my cluster. So maybe I send a notification when my cluster goes up, or I want to let everyone know when a certain deployment has worked in like a Slack channel or something. So I can do that by consuming those events. But what happens when I've set up my cluster? So I have my cluster, it's running, but maybe I want to actually use something in production. So what do I do now? The first thing I think is monitoring. So how do I figure out what is happening with my cluster? How do I know that I've allocated the right resources? How do I know that I'm getting the most out of my task and my service? How do I know if something's wrong? I think the easiest way is probably to do it is with CloudWatch. So I can see the CPU for both my cluster, but I can also see it at the task and the service level. And I would ultimately be consuming some of those events somewhere else to take action, but I can also look and kind of look at well, here's a snapshot of what my whole cluster looks like. So in this one, you can see CPU and healthy host count. So I might alarm on some of these, but I could also be like, OK, well, I want to just go see what my cluster looks like. So I pop in, and I can see that, OK, the CPU utilization is 15%, 10%, and then also my healthy host count looks like this. So you can get a lot of metrics there. You can add your own. But you can basically see the whole state of the cluster, the state of the service, the state of the task. And then you can also consume those events somehow else. So an example of that might be with PagerDuty. If, for example, you're on call, so you can consume the event with PagerDuty or another logging app so that you can monitor your whole cluster. You pick a logging driver in ECS. So when we talked about things that you could do at kind of the task definition level, you choose a logger. So Docker gives you a lot of options. AWS Logs will go to CloudWatch. You have other ones, though, too. So you can go to a JSON file. You can go to journald. The ECS agent GitHub repo is open source. So if you have something that you want to see, so if you have your own favorite log driver or something that you've worked on or your own favorite, open a PR and let us know on the GitHub page. And we look at those also. But you can add your own favorite log driver. With the AWS Logs one, I can set the log group so that I can sort it, because I think probably the only thing worse than no logs is having like terabytes of unstructured logs. And then it's like, well, what do I do if something actually goes wrong? How can I use this? So set a group, set a region, but use your own favorite log driver. And I think the right answer for all of these, right, is what's going to work for you? What can you get the most insights from? What's going to be workable for you? What's a way that you can look at it? What's a way that's going to help you in your company kind of get the most, help you learn about your infrastructure and help you get insights into how you can make things better? It ends up looking something like this, but I can pretty much shove everything at CloudWatch. I can label them, I get times, I'd end up sorting through them. So this is just things I shoved there, but you could do a lot better than I did on sorting them. You probably want to use a filter or a metric. I've added custom metrics before so that I could alert on them, but a lot of them are kind of fine with the stock version. So in this one, I've added a custom one, and then I can alert on that error. So when I see a certain kind of error, send it to PagerDuty, send it to my phone, send it to my email. Definitely filter them, though, because what's really not helpful is not only my unstructured log data, but getting a bunch of alerts. So I think anyone that's been on call has probably run into this, but you have the alert that it wakes you up, and then at 2 o'clock in the morning, and you're like, well, that can wait until tomorrow. And I think if it woke you up, you can't really wait until tomorrow. So you need to make sure that not only are you logging, not only are you alerting, not only are you monitoring, but you're doing that intelligently. So if something wakes someone up and it's not urgent, shouldn't have woken someone up. So make sure that you're kind of sorting or using severity levels so that you're alerting exactly what you need at the right time that you need it. So if something is just like hey, I might run out of disk space in 2 days, maybe make a warning so that people know that they need to take action soon, but it's not an emergency yet. Something really common that I think everyone gets asked is, but how do I do service discovery? And the recommendation that I used to give was to do it through DNS records, and we'll get to that in a second, but I think actually ALB is probably easier now. So I can pretty straightforwardly do this now because I can route my content based on path, which you talked about when we were looking at the load balancer, but it ends up looking something like Nothing. Goes to my main website /signin, goes to my login service /API, goes to my API. And as I add new tasks to that service, they're registered to that same load balancer. So that effectively is handling my service discovery for things that are being routed to through the application load balancer. That's not the only way. I think it's probably the easiest way. It's kind of like service discovery, but it's pretty seamless, because all I'm really doing is I'm writing target groups, and then every time a new task comes, since it's through that service, is registered to the load balancer. You can also do this with DNS. So a way that I probably would have done in the past, and I could still do it, I use a CloudWatch event, trigger something in Lambda, and that can add or remove a record in Route 53. So also pretty easy. A little less easy probably than doing the load balancer, but it's effectively the same thing. So when I have a new task come up, I add the record in Route 53, which works at the host level also. So if I have a new host comes up and I need a record for it, like if I'm using an allocation service, I could do the same thing. I could have a CloudWatch event when a new host comes up, runs a Lambda handler, adds a new record in Route 53, and then the same thing for if I remove one. So a task is removed or a host is removed, triggers my event, which triggers my Lambda function, which makes the change in Route 53. What about secrets? So there are different things, different levels of secret, I guess, right? And the textbook way is, well, I can pass environment variables in my task definition. So my name and a value. That's not really that great if it's really sensitive, though, because if I just go to the AWS console, I can just see that, which doesn't really seem secret. What that's great for is something like passing an environment, so production or staging, and then looking up that value in an actual secret key store somewhere else. So example might be in parameter store. So I can control, based on IAM roles, the tasks that can access which permission. So I set my IAM role at my task level, so it's effectively by service, uses the IAM role. I have prod.app or something, and I can use those as my environment variables so that I can feed in the environment name, but then I can only look up based on my IAM role. So that means that service A can get something, while service B can't. Service C can get two things. I think that's kind of a principle to keep in mind when you're building containers in AWS also, right, or anywhere, which is that you don't have to manage everything at just the instance level anymore. You can manage them at the task level. So it used to be, right, that I had an IAM role and a security group for my instance. And that was great, but it meant that any task on that instance had the same permissions. They could do the same things. And I don't necessarily want that anymore. So what I can do now is I can do everything at kind of the task and the service level. So if I have a messaging task, my messaging service, maybe it can access DynamoDB and Kinesis, but not S3. But then I have a service that's like my photo service, and that can access S3, but it can't access Kinesis and DynamoDB. So you can control, based on the job of that service, what it has access to and what it doesn't have access to. And that lets you be a lot more secure, right? Because you no longer have kind of one role for every service that can access all the same stuff. You can monitor performance with stuff like X-Ray. So what you can do is you can trace the connections this way. So this is my service map. But what I can do is I can dig into this. So I can run traces. So I can look at the latency, the number of the percent, the response time. I can dig into that for kind of all of my calls. So I can see, OK, well, you know, this call to this service is kind of slow, or this call to this service is really fast. And then once I've dug into that, I can see, OK, well, this is where I should focus all my energy if I want to make my deployments faster. So you have a lot of options out there for making sure that you're kind of getting the most out of your deployments. I am wrapping up here. This is on a live stream, so we're probably going to do pretty limited questions out loud. And also the room is kind of huge. So I'm going to stand to the side, to here, and then to the side right here. So if anyone has any questions, come and see me afterwards. I'm happy to answer anything. I'll hang out for a while. If not, I've been told to give you guys a little bit of wiggle room to get to the next session. so that you can get a seat there also. So I'll be standing right here. If you have any questions, come and find me. And if not, enjoy your next session and enjoy the rest of reInvent.